Hey everybody, Shawn here from the Automation Blog and School, and in this episode of the Automation Podcast, I sit down with Justin Shade of Phoenix Contact to learn all about their wireless product line.
Hey, Justin, thanks for coming on the show today to explain to us what Phoenix Contact has available in the industrial wireless land area.
Yeah, Shawn, thanks for having me. Yeah, like you said, my name's Justin Shade. I'm the Senior Product Marketing Specialist at Phoenix Contact for all things wireless. So I handle all the industrial WLAN products, 900 megahertz Bluetooth, some industrial cellular products, and some new short-range wireless technologies that we're coming out with here in the short term. A quick agenda here for you. Wanted to go over some new nomenclature we're hearing in the WLAN world, just so you are aware of some terminology that you may be a little different from the past. Look at some market targets and trends that we're seeing in the industry that are pretty hot, and kind of give you some background on why we have the products we have today. And then go into some product updates of where our product portfolio is and where it's going, and give you some ideas of some features and functions that we have that maybe be some benefits to our listeners. You've probably heard these terms. They're in the media, they're in the industry, they're all around the industrial world. Is Wi-Fi 6 or 802.11, you know, terminology. So the one thing I always talk to our sales teams and our customers about is, these terms, the Wi-Fi space number and then the 802.11 designations are synonymous with each other. So depends who you're talking to. The IEEE, who writes the specifications for the wireless LAN directives, requirements, uses the 802.11 letter designation. So 802.11n, AC, AX. And then the Wi-Fi Alliance, which is a different organization that kind of does compatibility testing more in the consumer world, has coined this new nomenclature, Wi-Fi space number. And it's a little more easily digestible to the common user. So you hear 802.11 AC, AX. If you're not a wireless person, you really don't know what that means. Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, it's a little easier to understand and listen to. You hear it, it's easier understood. So when you're looking at, going to a consumer place like a Best Buy or Target, and you're buying a router, you're going to see the terms Wi-Fi 4, Wi-Fi 5, Wi-Fi 6. If you're reading a standard or you're looking at an industrial radio, you may see the 802.11 nomenclature, or you may see both. But the important thing to know is they're the same thing. So there's nothing different between 802.11ax and then Wi-Fi 6. They're synonymous with each other. It's just a different nomenclature. And the Wi-Fi Alliance terminology seems to be taking over a little more, just because it's, I guess, easier to say and easier to understand.
Yeah, I was going
Um,
to say that because, A, B, G, N, A, C, that's all been, I think, if you're technical at all into Wi-Fi, those, all of those, right? They're very familiar. But I've heard more Wi-Fi 6 than AX.
Exactly, and it's all on TV, all on your commercials. Your internet service providers, your cellular providers. Again, your residential, your consumer products, your phones, your routers, your gaming devices. That's the terminology they're using. It's an easier to understand and easier to say
Mhm.
term. So if you haven't heard, or you have heard and you just didn't know why am I hearing one place and why am I hearing the other place, they're just a matter of preference of the user, but they're synonymous with each other. So going forward, if you may hear me saying both of them, because I depending on who my audience is, I tend to say both of them, so I may mix them up in our conversation today. But if I hear me say both, they're just synonymous, just a different way of saying it. So moving into industrial WLAN, one of the things I wanted to kind of preface here is kind of some trends and targets we're seeing from Phoenix Contact in the industrial world, to kind of give you an idea of, when we get into the product overview, why you see the product housings, the product physical features, and the functions of them, because we try to develop our products based on trends we're seeing in the market. So especially within the past 12 to 14 months, with the whole COVID situation, and how we've had to kind of push forward with more of an autonomous business, warehousing and functioning with warehousing and automated manufacturing. we've seen a lot of movement towards, again, autonomous vehicles, guided vehicles, where the warehousing and manufacturing, we haven't had the people in those places, or we've started to see a bigger mix to help make manufacturing and distribution more efficient. So we've started to see this trend where a lot more guided vehicle manufacturers are popping up. The guided vehicle manufacturers that we've known from the past have started to see increased production and need for materials. We've also seen manufacturing OEMs and everybody ramping up their production and wanting to connect more devices. So when you think connecting devices, it's not just, hey, I want to connect this one device. It's, hey, I want to connect this control cabinet worth of devices. So when you look at Wi-Fi as a technology, you think your phone, your laptop, your tablet, your connecting a device. Well, in the industrial world, there is that instance where, hey, I want to connect this one device, but you want to connect, you don't want to buy an industrial radio for every device in your control cabinet. You want to be able to take all those devices in your control cabinet and communicate it up to your infrastructure with one radio. So we're seeing a lot of users and end users and suppliers wanting to connect those devices, connect those assets to do predictive maintenance, to just cut down on the amount of physical man hours it is to go around and gather data, to be able to monitor and to be able to push updates to different devices without having to physically plug into them.
Yeah, I think if there's not already physical cable going to a location, automatically people know how much it costs to run cable, and they're like, can we do Wi-Fi with it? Is that practical? And I think that's the number one question when you have a new drop now, because everybody has Wi-Fi. It's not like it was 20 years ago, and everybody knows how expensive it could be to run new conduit and some Cat 5 or Cat 6 out there, right? So I agree with you there. It's definitely, it's like almost every question is like, if you got a new drop, can you make it Wi-Fi?
Exactly, and I mean, and that's the biggest thing. And I would say this comment: when you look at, you made a comment about everybody has Wi-Fi today. That's a blessing and a curse sometimes,
Yeah.
because everybody has Wi-Fi, so it's great to connect things. But everybody has Wi-Fi, so do I have the capacity of my Wi-Fi system to connect more assets? So again, one piece of advice I'd give to anybody who's looking to add Wi-Fi to their plant floor is make sure you involve your IT group right up front, because trying to go around that, they typically own that area of
Mm,
technology and
yep.
buildings, and they're much more open to having that conversation when you involve them early than you try to sneak around them and then install something and they find it later. It causes problems for everybody. It's not just a problem for them; it's a problem for you too, because there's interference. You're doing something that's more time sensitive, more robotics, and needs to have clear communication. And if you don't plan that out with other users on the plant floor, it could cause problems for everybody. So I mean, again, just make sure you're having those conversations. I have those conversations with OT and IT all the time. And again, as long as you're planning with them, usually it's okay. And it's, like you just said, if Wi-Fi is there and it's the capacity is there, why not use it? Take advantage of it. And especially in again, the warehouse area, you have all these different areas of industrial automation, and again, one big trend that's picking up are these automated robots. So you're going to have these areas like you see in the left and the upper right, where it's they call it a dark warehouse, where it's all automated. So you have robots roaming around picking and packing, or picking up and taking uh, product over to certain places so a human can come pick it up, but there's no physical human in that area. You have storage retrieval systems that are bringing materials down to people to pick and pack. And then you have the robots around the plant floor that are interacting with humans. So they have to run around the plant. They have to make sure that they're following a path, but also um, watching out for obstructions around them so they don't hit something. So all this is happening around your plant floor, and a lot of it's happening via Wi-Fi, yeah, Wi-Fi. So trying to connect these autonomous robots, as well as automating the storage retrieval system, with also having these guided vehicles that are in the dark warehouse. It's a big trend to automate the warehouse as a whole, and make those processes more efficient. Um, and when you look at these different robotic type vehicles, they're in all different shapes and sizes because they do different features and functions. So, You have shuttles that'll take materials from the storage system over to a manufacturing location, so a human can then take out those pieces and start doing a process. You have shuttles that are moving this material from one place to the other, so they can be stored different places. Forklift robots that are going in, picking up large pallets, moving large pieces of material from one place to the other. And that forklift could be, autonomous, or it could be, half and half, where a human is kind of running it, but it has an automated piece to it. But with all these different types of transport systems, you have different locations where that material is stored. And when you look at these things, they're always wireless. Well, for the most part, there's some kind of wireless interface to them. And depending on what type of platform you have to make sure that that wireless communication device can have clear line of sight to your access points for good communication. Otherwise, that asset's going to keep stopping and faulting. Um, so you can kind of break it down into two main types of vehicles. One that's a front load or a side load, like the forklift on the right hand side, and typically you'd have a control cabinet that has some kind of antenna or radio that's sitting on the top of the vehicle that has a clear sight line to your access points. But then you also have these top loaded vehicles that put all the material on the top, so you can't put the radio on the top of the machine. You have to put it inside the machine, and then somehow find spaces for those antennas to be in a good position, so that no matter how that vehicle moves or turns, it's able to have a good connection to whatever access points in the area. So trying to find, on that shuttle on the left, trying to find a product that will fit in that small cramped spot that the vehicle has, and then B, that the vehicle has, or the radio has antenna connections to move to the sides of the vehicle, and the vehicle has spaces to mount those antennas. Again, with vehicles like this, or any wireless, maintaining good sight lines to the access points and good signal strength allows those vehicles to work autonomously. So we have a strong trend with these automated vehicles, and that's kind of where our focus is when we come to a kind of like a hardware and software design, is that we try to design around the needs of automated vehicles like this, but also the needs of industrial automation for control cabinet design and mounting as well. And that's where we kind of come into where our portfolio is today. We have two new product areas: the FL WLAN factory line, WLAN 1000 series and 2000 series. And within this series, we have two main models. One that's going to be an external to the cabinet IP rated device, and one that's going to be an internal to the cabinet device that's on a DIN rail or panel mount. But the nice thing about the portfolio is the software engine is the same as for both. So what we're trying to give you is multiple options that have all the same feature sets, but provide the user the flexibility to mount them wherever they need to mount them. They have control cabinet space, they can mount at the control cabinet. If they don't have control cabinet space, they can mount it on the outside of the control cabinet, but they're not losing the features or functions by going to one hardware platform or the other. So to start, this is called our 1101 and 2101 series. So this platform is a IP rated device. So the radio itself is all encompassed in an IP rated housing. The 1000 series, the 1101, has an IP54 housing. The 2101 series gives you the opportunity to go up to an IP68 protection level. So whatever you're mounting that radio to, whatever that IP rating of that cabinet is, the radio will adhere up to IP68. The radio is a multi-function radio, so you can be an access point, so it can provide access to a wired network via wireless communication. It can be a wireless client that connects to an existing infrastructure. So if you're in a warehouse and there's already your IT infrastructure is already there, our radio can connect to that third-party access point that's already there. Or if you need to extend the range of your wireless network, say your end node was too far out of range of a home run shot for a wireless communication, the radio can act as a repeater and be an intermediate step between an end node and the access point. So it can kind of be a bridge in the middle. This platform also has two integrated antennas inside the housing. So when you look at needing to order or your bill of materials for a wireless system in general, you usually have the radio plus some adapter cables, maybe some surge protection depending on where the antennas are being mounted, plus the antennas themselves. Well, this radio again has some higher gain antennas built into the housing that provide kind of a dome-like radiation pattern around the radio. So if you look at the picture of this right here on the control cabinet,
Mm-hmm.
you kind of get this dome-like radiation pattern that kind of radiates in all directions. So it kind of gives you full coverage around the radio and what it's mounted to. And then when you look at the 2000 series there, all those functions are there, plus you get a little higher temperature range, -40 to 60 instead of 0 to 60, which the 1101 is. And then I'll talk about this a little later. We also have this mesh function into the radio. So we talked about these client access point repeaters. You also get a mesh function here in the 2000 series. So a little more in depth what the housing looks like. So if you blow out this housing, you can see inside you have your IP54 or IP68 housing, and then you have a special antenna board that's built to fit inside the housing. So you can see there's two antennas. One's more of a directional antenna. One's more of an omnidirectional antenna that gives you that dome-like antenna radiation pattern. Then you have your Wi-Fi radio. Then on the bottom, again, it has a single hole. So if you think about a guided vehicle, you think about a control cabinet, anywhere you put a radio inside a control cabinet, best practice is you get an antenna outside that enclosure, maintain, again, good signal strength, good line sight. So you're gonna have to punch a hole in your control cabinet one way or another. You just gotta punch a little bigger hole, and then you can mount this radio right on top. And the big benefit there is it's space savings. A lot of control cabinets are already, tight for space. Some of them even have, heat dissipation ratings that you don't. Adding another thing has to redo the whole classification of the cabinet. Specifically in guided vehicles, there's so many things in that control cabinet. Adding another thing is tough. So this keeps it outside the enclosure for the user. And then on the bottom you have just a standard RJ45 and then a 9 to 30 volt DC power input. So again, on most industrial applications, you have 24 volt DC power supply in there, just connected right to the power supply. Or if it's a solar powered application or a battery powered application, you can run that radio off that power supply as well. So if you look again on top of a guided vehicle, forklift, for example, you just punch a hole in your enclosure here. Instead of having to run antenna cables up or outside, you have your motion, your guided vehicle control system in here, your PC or whatever. You just run an Ethernet cable right to it. It's a one part number for the whole system. You don't have to worry about ordering all the different parts and pieces to that antenna assembly, and it mounts right to the control panel. So again, it's an easy way of building a wireless system. The one con to this type of application is if for whatever reason you're doing a little longer range wireless connection, there's no way to extend that antenna or create a higher gain antenna. It is what it is for that application. So we're just getting ready here to release here in by the end of the month here. It's cousin, and you'll see the name is fairly similar. We switched the one here. It's 1011 and 2011. And again, everything we talked about with the 1101 and 21 was the same, except for now it's a DIN rail / panel mounted radio with external antenna connections. So you get all the access point, client repeater functionality. Both of them if you're in a hazardous area. So if you need a class 1 division 2 rating for, potentially hazardous areas, the whole family has class 1 div 2 area ratings. The 2000 series again has that mesh network functionality that we're going to talk about here a little later. So again, we're not taking anything away from any of the from the user from taking the DIN rail mount panel mount IP20 version versus the IP54, IP68 rate. We're just giving options to the user to mount it in different ways. So this one comes mounted panel mount, and there's also a DIN rail mount adapter that you can get along with it to mount it on its side here. And you can see very similar things. You'll see some panel mount holes, so the customer wants to mount it on the inside of the panel, or if it's not a wash down or wet environment, they can even mount it on the outside of the panel. You have two antenna connectors for that multiple input, multiple output antenna setup. Same power, 9 to 30 volt power. LEDs for indication on diagnostic indication. And what's a cool thing here is that they're adding this little QR code. So what happens with the radio when when you get it out of the box is it broadcasts an SSID, and if you scan that QR code with your phone, it gives you that information so you can log into it and configure it via a smart device. So it's a nice little added feature for ease of use for the user on initial configuration. You see them all the time. QR codes are popping up all over the place for enabling access, giving passwords, signing into your TV at your smart TV on Disney Plus or whatever. You're seeing these QR codes everywhere. So it's a nice little feature to allow ease of use for the initial configuration of the device.
Nice.
And you can see it's very compact. So it's 26 millimeters wide. If you mount it on a DIN rail on the connector, which is optional, again, it becomes very, very thin on that DIN rail mount, the
nice.
DIN rail connectors. So I mean, they've done a great job with the hardware design. I think there are it's almost smaller than some 5-port switches from a thickness on the rail. But it also, you have the panel mount. So if they don't want DIN rail space, you can mount it on a door, mount it on the outside of the cabinet. There are some DIN rail or panel mount adapters there for it as well.
Yeah, I thought it was going to be the DIN rail connector was going to be on the bottom. This is much better. You're right. It's just like a industrial switch now.
Yep, and that's kind of where the housing design came from. Is you look at that top-loaded guided vehicle or automated vehicle, you need something small and you need something panel mounted. In these vehicles, all the smarts is in this bottom platform here on the bottom. If you ever see you open up a lid and there's batteries, there's laser rangefinders, there's industrial computers that are sitting in the bottom here. There's no room for anything in that box. So they needed, we talked to some guided vehicle manufacturers and said we need something that can mount outside that enclosure, but also, we can't put the antenna on top or on the side of the vehicle, because if we put it here on the end, when this thing turns around away from the access point, we lose connection and the thing will fault. We need a way of putting antennas on each end of the vehicle, so whichever way it turns, we're able to maintain good sight lines to that access point. So that's kind of where this panel mount flat housing came from. Is a lot of these vehicle manufacturers have some space they can mount these radios to the vehicle itself, and then run antenna cables to either end of the vehicle, and that way it allows them to have connectivity on however way that vehicle turns. All right, so wanted to get into some of the extra software features now. Talked about the housings of the radios, but now what can you do with the radio other than, hey, I can connect my device to a network, or I can be the network. So the first thing, again, trying to accommodate all the different types of users there are now. So me growing up with Phoenix Contact and seeing, how wireless is configured. I'm a web-based management type of guy. I like to get into web-based management, which is fine for when it comes to, you have a couple radios here and there. You can get in the web-based manager, configure them. But if you're configuring 10, 15, 20 of them at a time, 30, going into the web manager 30 times is not efficient. So this platform, we've introduced a couple different ways that allow you to automate it. So if you're an IT person, IT really likes command line interfaces. So we have a command line interface to the radio that they can get in through SSH and configure the radio, write a script to configure the radios as they need, update and everything. Or if you're more of a programmer, REST APIs are a really, really big thing right now. And we just introduced REST APIs to both platforms. So someone can take those REST APIs, pull them into their control platform, and automate configuration, pull diagnostics, schedule things that security has been in the news really big the last couple of weeks. So if you rotate your Wi-Fi passwords, right? So if you don't want to go out to each individual radio and change the Wi-Fi password, there's a REST API that you can there to configure the Wi-Fi password for the network, allowing the user to again have flexibility and configure the radios, pull diagnostics, pull statistics from the radio, and then configure them as they need to, and automate that if they want to. So it's giving the user different options. And these are all, again, built into the platform. There's no add-on modules that need to do this. It's kind of built in. But if you want to go a step further, Phoenix Contact does offer for our whole networking line. So this is not just Wi-Fi wireless LAN, but it's our managed switches, some of our security devices, a centralized network manager. So this is a Windows-based software platform that you install on a device, and you can configure multiple devices, pull diagnostics, send SNMP traps to the software, and manage all those devices from a central location. So this is again a network manager platform that we sell to users to then be more efficient with their configuration and management of their devices. So this one goes a step further and gives you insight to the rest of the Phoenix Contact networking family as well. So one of the configuration options we have with the radio is some routing functions as well. So if you look at, again, any OEM manufacturer who builds control cabinets for multiple customers, or again, if you take the example of a autonomous robot manufacturer, a lot of the times there's service contracts that go into those sales. So a guided vehicle manufacturer will sell service, year service, or 3-year service to come out and do diagnostics, firmware upgrades, whatever. Or the OEM manufacturer, the control cabinet, will sell warranties on service. So one thing that's really popular in configuration of those control cabinets and those guided vehicles is one-to-one NATing. So what that allows the builder of the unit to do is construct that device, that control cabinet, exactly the same from an IP perspective every single time. So if they say, hey, every control cabinet I build, my PLC is going to be 0.10, my IO block is going to be 0.20, and my drive is going to be 0.30. That way, anytime my technician plugs into that control cabinet, I don't have to search around and try to find the IP addresses. But then they sell that control cabinet to a customer, and their customer's network is 10.150. What we can do in the radio is we can take a device or multiple devices and NAT that device's IP address. So inside the control cabinet, we can keep this 0 dot network here for our technician who goes out to do maintenance. But when that traffic comes up to the customer's network, the customer will see it at the IP address scheme that they want to see. So we'll take 0.10 here, and we'll translate that up. When it comes up the wireless interface, it'll be 10.10, so that the customer's network understands that packet. And when it goes back down, the same thing. It'll be anything coming from 10.10 will be translated back to 0.10.
That is a great feature. I wish every device had that. But let me ask you a question on that. Is it only on a one-to-one basis? In other words, I can map 1010 to 010.
Mm-hmm.
This device can only have one IP address on the company network, correct?
So that's a good question. So the radio itself will have a what's called a WAN and a LAN IP address.
Yes.
So the radio itself will have a 10.x net IP address when it's communicating up. If you plug into a switch here in the control cabinet, it'll have a 0 dot network here locally. So if they can access the radio here at the 10 dot network, they can access it here at the 0 dot network. This NATing function
is on
have
top of that.
Rules.
So, in this case, the WAN network for the device is .111, 10.111.
Mm-hmm.
If I wanted to program the device, the WLAN device, I'd go right to it. And it looks like you have a :80 or 80. That's just web page. Is that how I'd access its web page to configure it with the :80? Or I could just probably type in the 10.111.
Exactly. So if you're coming from the wireless side, if you're connected to the wireless network, you'd access the radio at 10.111. If you're on the wired side, plugged into the control cabinet, you'd access the radio at 0.1.
So, but what you're saying is, I'm not reusing 10.111. You're saying inside the device, I can say 1010 goes to 010, 1020 goes to 020. So I can build a table, a one-to-one table. That's very cool.
Great. Yep. Yeah, and the one thing to pay attention to, like any other thing, those the IP addresses that you're NATing, so these 10.10, the 10.20, the 10.30 you're mentioning, have to be reserved on the customer's network. So usually what they'll do is when you come in, they'll say, hey, here are the IP addresses for your devices. Use these, don't use anything else. So we would just take those and say, hey, 10.137 is 0 to 10, 10.55 is 0 to 20, and et cetera, or whatever your customer would give you. Yep.
That's great. That one-to-one NAT table in there. That's pretty awesome. Yeah.
Yeah, and it's not, it's nothing groundbreaking. It's something that, we have NAT switches. We have switches that don't do NATing. We have security devices do NATing. But if you need to be wireless and do NATing, we're taking the need for having two devices away. So now you can do it in one device.
Yeah, and I don't think you find a lot of just standard industrial switches that have NAT table built in. So, or maybe in the Phoenix line, but in other lines, I think that's always an add-on that always seems to throw you into a specialized device or into a layer two switch, or something in between.
You usually see it again when you get into these kind of functions. It's usually you're getting into the router level, right? So
Yeah.
you're getting into a higher function device or a quote unquote security appliance, right?
Mm,
So it does tend to get to that higher price point.
mm.
And again, now even if that you need two devices, so now you need a radio and a NATing device. So you're taking up more control cabinet space, and you're paying a premium to have the router and a second device as well.
Yeah, exactly. This is a great feature.
Yeah. So again, this is great for, those guided vehicle manufacturers, OEMs who build control cabinets, anybody who wants to build the same machine or does service contracts for, their devices. Again, the caveat to one-to-one NATing, that's not one-to-one NATing in our device, just one-to-one NATing in general, is that you have to have, these IP addresses here reserved up in the customer's network. Sometimes, depending on how big the customer is, that can be a problem. So another thing we offer is IP masquerading and port forwarding. So a similar application, take that exact same use case. So we have a manufacturer of a control cabinet. They put in these devices and they have their IP scheme in the control cabinet. But the customer wants it to be 10.x. But the customer says, you know what? I only have one IP address for you. I can't give you one for the radio, one for the PLC, one for your IO block, one for your drive. I just don't have that many available. What you can do is you can do IP masquerading and port forwarding. So in the radio, you'd say, hey, anything coming into my LAN going out my wireless port is going to look like IP address X, so 10.111 when it goes up to the wireless thing. So everything here is going to say 192. When this PLC sees it, it's going to be 192.168.10.111. We're going to masquerade the IPs of everything coming off my LAN port. When it comes back down, if it needs to come back down, it may not need to come back down. But if the PLC needs to communicate back down, the PLC can then talk to the radio on specific ports. And in the radio, we will map those ports to specific IP addresses. So if this PLC needs to talk to this PLC, we'd say, hey, talk to IP address 10.111 on port X. In this example, it's 5001. Whatever port you may need, it's dynamic. So you can configure those ports in the web manager. So now we have the same application. We're keeping the IP scheme in the control cabinet the same, keeping the customer's network the same, but now we don't have to have 4 IP addresses, one for each device. We can have one IP address for the whole control cabinet, which then helps with customers that have more devices. They don't have to maintain all these IP addresses for that new control cabinet comes in.
And that can be huge on a service side if we're looking at, my background, regular control systems, not automated vehicles. If I only can dedicate one IP address for that panel on the WAN, on the company network, by doing this, it still allows me to get to each device in the panel. Maybe it's a VFD, PLC, an IO drop, maybe it's an HMI. With this, I can still access each individual one.
Mm-hmm.
It's really cool. I mean, that's a great thing.
And again, it's nothing new from a networking standpoint. We're just putting it into the same module. It now allows the customer to have a little more efficient, design in their control cabinet, reduce the number of parts in their design, and get the same functionality they're looking for. This gives some low-level routing available to the customer in a wireless device.
Yeah, and if you didn't have this, you probably would be looking at a router, and you would have to set up a routing table, or on your computer, you would have to know, the routing table. That would all have to be set up correctly. This is just automatic. You fill in the table, and you're good to go.
Yep, and again, with any application, whether it's wired or wireless, the more devices you add in that thing, the more points of failure you have for the communication, the more place to point the finger at. So again, we're just reducing those places of failure and reducing the number of parts in the control cabinet. So those are two, I guess, network routing things we do. Another cool feature here is on the wireless side, and this is a term that I hear all the time that I think it's one of those buzzwords. It is mesh. I hear all the time when I talk to engineering firms, system integrators, end users. Hey, we need wireless mesh. And usually the question I ask them is, oh, okay, so tell me what you're doing and why. Define what you mean by mesh. And usually it's something like, hey, I need to make sure this wireless connection is strong, and if it were to drop, I need it to self-heal. And I go, okay, that's great. That's not a mesh. That's the self-healing network. So when we talk about mesh, mesh means that every node in the network can talk to other nodes. So every node knows who their neighbors are, what the signal strengths are. If I talk to this neighbor, they have another path to another neighbor. So that if that breaks, if something breaks somewhere, we have a redundant path back. So if I'm trying to talk from this PLC down to this device down here, I have a path here that can go here, that can go here, or if this path breaks, I can go here. Every node knows who their neighbors are and is able to pick the best path at any given time to maintain a reliable connection. So an example we had of this recently was I was in a water park in upstate New York, indoor water park, and they had windows that they open and close for let humidity in and out. And not that it was a long distance application, but there were water slides, there were scaffolding, everything from the middle of the water park where the food court was, where the SCADA controller was, to the furthest endpoint where the window was. So instead of having to try to shoot signals, point, in a star network from the access point through all this water slides and people and stuff, we were able to put there's clear line of sight. If you're looking, you think about like a stadium, you're in the middle of the stadium, look to the left and right up to the top of the stadium, and then down the line they were 50 feet apart from each other. We were able to make connection direct line of sight to the windows on the side, and they were to hop, instead of trying to hop and go through obstruction, we were hopping 50 feet from radio to radio to radio. It wasn't time sensitive communication. It was, hey, I need to open the windows to this depth, hit the button, and the windows open. So the focus of this wireless mesh is to create a private network that's redundant and allows you to cut down on these star type networks, long range communication. So again, if you have communication from devices, there's multiple paths. If that path were to break, it can find another path home.
Isn't another part of mesh though, you have it there as a bullet, mobility and network? Like I have an automated vehicle that goes between two buildings, and I just wanted to. I don't want to have two different SSIDs. I just want, as it transfers between buildings, it can pick up the network on the other side of in the new building versus the old building, or do I have that wrong?
It can be. So I think what you're describing is called roaming. So think about in a hospital or a school. You're on your phone. You're walking down the hallway. Your phone's going to connect to an access point, and as you move away from that access point, it's going to move to the next access point. In that topology, in the ceiling, all those access points have a cable that runs back to a closet, to a big switch, and that's where all the traffic goes. So even though to a user as you're walking, it looks like a mesh, right? Because you're talking from access point to access point, but in the background, on the back side of that radio, there's a wire. In this setup here, there's no wires between these devices.
I got it.
So there's a wire to this control cabinet. There's a wire to this control cabinet. This is the backbone network, so there's wires between these two, but there's no wires between these four devices and these devices here. And that's the main difference, is they're using wireless communication as that wire to create that network infrastructure. Now, the downside to mesh is, again, depending on how it's implemented, depending on the radio or radios in the housing, there is significantly more overhead in the protocol, because you're not only just in a standard access point setup, you're beaconing, you're hearing probes from clients to try to connect to the network. You're sending traffic back and forth. With a mesh, you're doing all that at the same time. You're doing all that, but at the same time, you're sending neighbor reports to all your neighbors. So this guy, every interval, is going to say, "Hey, I'm radio one. I have signal strength X to this radio, signal strength X to this radio, signal strength X to this radio. I'm sending it to him. I'm sending it to him. I'm sending it to him." And that communication has to happen in between data traffic, in between standard beacons, in between probe requests from other radios trying to join the network. So the airtime utilization that can increase with a mesh network can be significant depending on what the application is. Again, there are very high functioning radios out there that can do that mobility and do it really, because they'll have one radio inside the housing. They'll have one radio doing the management traffic and one radio doing the data traffic management. So depending on that, that's kind of where you see the price go up, is they have multiple radios doing different functions, but to the user, it's one radio, it's one housing.
Oh, I see. Yeah.
So what our mesh is meant to do is, again, we in the beginning we talked about, hey, the OT and IT collaborative, make sure you're talking to each other when you're deploying new systems. What's really great about this kind of mesh functionality on the factory floor is, if you don't want to, if there's no reason to, or there's a security reason, or there's just hey, we don't want your factory floor network on our IT infrastructure, or it could be the opposite way around. Hey, we don't want to touch the IT infrastructure.
Mm-hmm.
You can create a private network here where only thing that talks to these radios are the radios, and these machines can talk to the machines and never touch the SAP system, the ERP system, all that HR system here. We never touch it. You can create your own private little network on the plant floor and never have to communicate to that IT infrastructure at all. So it just depends on the use case. Again, that water park was one instance. I had another application again where it was out in, I don't remember where it was, but it was going to be the biggest cow milking plant in the country. It was going to be like 30 football fields of cows.
Wow.
And milking. And they had these big fans they had to put in the ceiling to keep the cows cool. I mean, that's what it was for, to make sure they don't overheat. And it was a washdown environment, kind of like an FDA approved thing, where they couldn't, or they didn't want to at the time, run data cables all over the ceiling and all these fans. They had I think the 240 or the 480 volt power going up to the fans, but they didn't want to run any of the cables. So what they were planning on doing at the time was, again, these fans were 100 feet apart, was just have a radio on the floor, and in different areas have multiple of these radios on those control boxes for those fans, and just have them create their own mesh topology in the ceiling to talk from fan to fan to fan to fan. So they have to run cable between each fan every time they want to turn the fan on. It wasn't time sensitive. Hey, turn the fans on.
Sure.
They need to turn on. Done. So it's kind of like a SCADA application over Wi-Fi. So it's a neat function. We're starting to see more and more of this mesh functionality popping up. And the other nice thing too is it allows you to have virtual access points as well. So the meshed function on the radios is proprietary to Phoenix. So a nice security feature, if you create this mesh network, you can't take a third-party device and connect into the mesh. You'll see an SSID, mesh network. If someone tries to connect to it and it's not one of our radios, it won't allow it on, even if they have the right password. It won't allow it on.
Nice.
So what you can do is create this virtual access point. So the radio has two interfaces to it that you can create the mesh network, and then as needed, where you need it, you can create an access point function, which is a standard access point, just like you'd see in a regular building. And then your tablet, your laptop, your phone can come in, wirelessly connect to that interface, and then from there they can access any node in the network. So again, it just allows you to have that flexibility to have a private network, a secure network when you need it to be, and then again through REST APIs, through some kind of scripting. Customer can come, maybe there's an HMI here on the machine. They can come hit a button, sends a command to enable that second interface. It has the virtual access point. Maybe there's a timer on it that says, hey, in 30 minutes, turn that off. It gives the customer the ability to make those configurations, make those automated functions available to their users.
Excellent. And that's an excellent case study, because leaving an open connection is always a bad idea.
Yep, and again, the same thing, that virtual access point is taking up the same, is working on the same channel as the mesh. So we talked about all the neighbor reports, the beacons, data traffic. That access point is going to create more channel utilization. So you don't want to necessarily have it on all the time just to have it on all the time. It's encroaching on your airtime. So being able to turn it on and off when you need to, turn it off on whichever device you want to when you need to, is a a nice flexible thing for the user to be able to do. With that, I just wanted to kind of recap what we talked about. Again, looking at where we are in the world today, with especially post COVID, where a lot of manufacturing is going smart, a lot of devices, a lot of machines and everything are getting connected now. Where we're looking from a Phoenix Contact standpoint is to provide a hardware platform that is flexible for users to be able to mount devices and put devices where they're able to put them, whether that's outside the panel, through the panel as an antenna, on a panel mount where they put it on the outside, or in the inside via panel mount, or on the DIN rail like they're used to, creating that compact space-saving device. And then taking that a step forward, providing an easy configuration option depending on who's configuring the device anymore. A person like me who's used to web managers, a more IT focused person who likes command line interfaces, or the more modern programmer now that likes standard configuration like REST APIs, giving everybody the way an option for the way they like to configure. We have those nice routing functionalities for NATing for those OEMs and cabinet manufacturers, to provide one-to-one NATing, that IPmasquerading and port forwarding, and then on the wireless side, providing users that mesh functionality that if A, they don't have an infrastructure that they can create, or B, they can't use an infrastructure, or even C, they just need to stretch a further distance than a typical Wi-Fi radio can do. You have that mesh functionality that can help you extend your network or create that private network for the end user. I think I covered most of it for you, Shawn. Do you have any other questions that you had?
No, Justin, that was great. Thank you for coming on the podcast and running through all those different the features. It really does seem like a good current gen product. It's not a lot of products that come out, they seem to be back, a couple of generations, but having the built-in, one-to-one NAT table, the mesh feature, access point, bridge. I mean, just like you checked every box that somebody would want, I think, in a wireless product. And I really appreciate you taking the time to go through it with us today.
Yeah, I'm happy to be here. I'm excited to talk about new products. It's always fun to talk about new technology and new things that are coming out.
Well, I hope you enjoyed this episode, and I want to thank Justin for coming on the show and taking time out of his busy schedule to give us an update on the Phoenix Contact line of WLAN products. Now, if you're watching on the blog or on YouTube, please consider giving us a like and a sub. And if you're listening to the audio-only edition on iTunes, Spotify, Pandora, TuneIn, iHeartRadio, or somewhere else, please consider subscribing there and giving us a good review, because that helps us reach a bigger audience and helps us find new presenters to come on the show. With that said, if you ever want to get in contact with me, you can reach me over at automation.locals.com. And with all that said, I just want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.